Did you know that your workout isn't just building muscle? In fact, exercise has surprising effects on your blood, and these changes can make your body much better. Want to know how your blood gets a workout boost? We're diving into the science behind exercise and your blood sugar, along with some tips to maximize your fitness gains. Buckle up and get ready to learn something awesome about your body. Nutrients and waste products are transported to and from muscles through a sophisticated network involving the heart and blood vessels. Primarily, the heart pumps oxygen-rich blood through arteries, such as the femoral artery for muscles like the quads during exercise. Branching off from these arteries are smaller arterioles, delivering blood directly to individual muscles. This artery network leads to capillaries, crucial for nutrient and waste exchange within tissues. Capillaries serve as complex exchange vessels, facilitating the transfer of nutrients and waste products between the bloodstream and body tissues. This exchange ensures that muscles receive essential nutrients for energy and growth, while efficiently removing metabolic waste, optimizing performance and recovery. The continuous circulation of blood through this network ensures a constant supply of oxygen and nutrients to active muscles, enabling sustained physical activity. During exercise, the muscles receive carbohydrates, energy sources, and oxygen through capillaries, while expelling metabolic byproducts like carbon dioxide. These substances flow into the bloodstream via capillaries, entering systemic circulation where the body processes them. Consistent exercise leads to increased capillarization, meaning more capillaries develop and extend into muscle tissue. This enhanced capillary network facilitates better nutrient delivery and waste removal, optimizing muscle function and adaptation. It demonstrates the importance of capillaries in exercise, as they enable efficient exchange between blood and muscles. Increased capillarization reflects the body's adaptive response to regular physical activity, enhancing tissue perfusion and overall metabolic efficiency. While growing more capillaries doesn't directly change blood composition, it amplifies blood volume. Consistent exercise stimulates the body to boost blood volume, facilitating more efficient nutrient delivery to muscles. This surplus improves exchange within the cardiovascular system, enabling the removal of metabolic byproducts from active muscles. With increased blood volume, muscles receive a greater supply of nutrients, promoting optimal function during exercise. Additionally, this process supports the efficient removal of waste products, contributing to overall performance and recovery. Thus, while the blood itself remains unchanged, the expanded capillary network allows for a more robust physiological response to exercise, highlighting the significance of capillaries in optimizing athletic performance. One crucial adaptation during exercise is increasing the overall blood volume, enhancing its carrying and exchange capacity. However, another vital consideration is the composition of blood. Understanding its components reveals two main parts. First is plasma, a fluid comprising water, electrolytes, and plasma proteins. Increasing blood volume involves consuming water and electrolytes, while the liver aids in producing more plasma proteins. When we talk about blood, we're talking about two main things: the fluid part, called plasma, and the cells floating around in it. The cells we're interested in for exercise are called red blood cells, also known as erythrocytes. These cells have a really important job. They carry oxygen throughout your body. So, if there's more fluid in our blood, it makes sense to have more red blood cells to carry all that oxygen. Your body does this by making more red blood cells in something called red bone marrow, which is deep inside your bones. So, when you exercise regularly, your body adjusts by making more red blood cells to keep up with the demand for oxygen. This helps your body work efficiently during exercise and makes sure all your muscles get the oxygen they need to keep going strong. So what's happening is that we've increased the number of tiny blood vessels known as capillaries that reach into the muscle tissue. These additional capillaries mean there's more space for blood to flow into the muscles. As a result, more fluid, carbohydrates, fats, and red blood cells can be transported to the muscles, bringing along with them essential oxygen. This inflow of nutrients and oxygen into the muscles is vital because it enables the cells to produce more of the energy currency known as adenosine triphosphate, ATP. When muscles have a greater supply of ATP, they have more energy to utilize during physical activity. This excess supply of energy can significantly enhance your fitness level and athletic performance. Now let's dig into which types of exercises are most effective at prompting these physiological adaptations. Initially, when someone who hasn't been physically active for a while starts exercising, Almost any form of physical activity will lead to an increase in capillarization and blood volume. However, as the body becomes more accustomed to exercise, certain types of exercises prove to be more efficient at stimulating these adaptations. Typically, endurance-based exercises, which involve sustained, low to moderate intensity activities over a long period, are particularly effective in promoting the development of capillaries and improving cardiovascular endurance, thin of a steady-state cardio, like cycling or running. If you've been part of the endurance athlete community, you might have heard about different intensity levels, often referred to as zones. Zone 2 is one of them. It's a moderate intensity level where you're working, but can still comfortably chat with a running buddy. Now, this doesn't mean you can't trigger these adaptations by pushing into higher intensity zones like 3 or 4 for more vigorous endurance training. The thing about Zone 2 is you can do a lot of exercise without feeling burned out or overworked, allowing you to accumulate a significant amount of training volume throughout the week. This volume of exercise, not to be confused with blood volume, can provide a substantial stimulus for adaptation. However, as you increase the intensity and moving into higher zones, you start engaging more of the fast-twitch muscle fibers. These fibers don't rely as much on oxygen and blood as the slow-twitch fibers do, which means the adaptations they undergo are different. Another way to promote increased exercise adaptations related to muscular endurance, blood volume, capillarization, and red blood cells is through specific types of resistance training. In this case, the focus should be on enhancing endurance strength. This involves exercises such as push-ups performed to failure or bodyweight activities like squats, where you aim for 15 to 20 repetitions or more to really build that endurance in your muscles. These exercises that target strength endurance not only stimulate the desired adaptations, but also benefit from them. For instance, improving the number of push-ups you can do or enhancing your ability to run longer distances more efficiently are common outcomes. Many people who have engaged in regular exercise are familiar with these concepts and their practical applications. They generally understand that specificity is crucial in achieving exercise goals. What I mean is, if someone's primary aim is to run a marathon, they'll primarily focus on running. It wouldn't make sense for a marathon runner to spend most of their time on heavy resistance training, and vice versa. However, there might be some incorporation of other exercises in smaller amounts. Now, you might wonder, can this approach also benefit strength and explosive activities? Well, it's a bit of yes and no. While it's true that increased capillarization, blood volume, red blood cells, and oxygen won't significantly impact one's 1-rep max or heavy sets of 4 to 6 reps in the moment, or activities like vertical jumps or sprints, they do play a role in recovery and overall endurance. Metabolic byproducts like lactic acid, produced in fast-twitch fibers during intense exercise, can be transferred to neighboring slow-twitch fibers in the same muscle. These slow-twitch fibers can then process these byproducts with the help of increased capillarization, blood volume, and oxygen supply. So while these adaptations may not directly enhance performance in maximal strength or explosive activities, they can aid in quicker recovery between sets for weightlifters or during breaks in basketball games, like during free throws, potentially allowing for more sustained performance over time. By integrating elements of steady-state cardio or strength endurance exercises into their routines, athletes can experience improved recovery between intense bouts of activity. This means they can bounce back more efficiently during breaks in play, such as timeouts or between sets, ultimately contributing to better overall performance on the court or in the gym. The flexibility to include these complementary exercises shows the importance of a well-rounded training program tailored to the specific needs and goals of each athlete. It's about finding the right balance between different training modalities to optimize performance and minimize the risk of overtraining or burnout. That's all we have for today on how exercise supercharges your blood flow. Remember, any activity is a great start, but for a real performance boost, consider incorporating endurance training like running or cycling. Don't forget about strength endurance exercises. Those high-rep squats or push-ups can be your secret weapon. While these adaptations might not directly make you a weightlifting champion, they'll help you recover faster and perform better overall. So, ditch the elevator, grab your running shoes, and get ready to experience the power of a well-rounded workout. What do you think? Tell us down in the comments section. Hit that subscribe button for more science-backed fitness tips. Share the video with family and friends. Thank you for watching, and we'll see you next time.